Hi everyone, this is the first video that I'm doing in a series of revision videos for A-level physics. The first topic that I'm going to look at today, going in the order that I would normally teach it in, is quarks, hadrons, baryons and mesons. And just before I get started, I just want to bring your attention to page 2 on the AQA physics datasheet, which has got a lot of information on which I'm going to refer to during this tutorial. And it's also in your exam, and it's really important that you go back and you make sure that you're using that information on page 2 of your datasheet so that you don't just make any silly mistakes that people fall into the trap of, basically. Okay, so I'll get started. I'm going to talk first of all about the types of particles and their properties that go with them. So we've got their charge, their baryon number, strangeness, and their symbol. Okay. And the first one I'm going to talk about is an up quark. And that up quark has got a charge of plus 2/3 of the elementary charge. So that's plus 2/3 of an electron. It's got a baryon number of plus 1/3, a strangeness of 0, and we give it just a symbol of U, which just makes it a little bit easier to talk about when we start doing particle interactions and things like that. When I teach this topic, I teach it with Lego bricks, because the Lego bricks stick together. You can start to look at how the quarks and the particles interact. So a yellow brick there represents an up quark. Next, we've got a down quark, which has got a charge of minus 1/3 of the elementary charge, or minus 1/3 of the charge of an electron. But it's also got a baryon number of plus 1/3, and that's an important property that sort of links together to how we form these groups of particles here: hadrons, baryons, and mesons. It's got a strangeness of 0, and we give the symbol D, like so. Okay, and we represent that with a red Lego brick. And the last one I'm going to talk about just for the moment is the strange quark. And that quark's got a charge of minus 1/3 of the elementary charge, a baryon number of plus 1/3, and a strangeness of minus 1. And that's quite a common thing that people fall into the trap. They think that the strange quark has got a strangeness of plus 1. It's actually got a strangeness of minus 1. So don't make that mistake when you start looking at particle interactions a little bit later on. And we give it the symbol S, and I always represent it with a yellow Lego brick. So there are lots and lots of other quarks, but I'm only going to talk about these 3 because these are the ones that you're required to know about in your A-level physics. There are other ones called top, bottom, charm, and things like that, but we're not going to touch on them because all it's going to do is confuse you at this stage. So these are the quarks that you need to know. All of the quarks also have what are known as antiquarks, and they've always got the opposite properties to the quark itself. So if I take an anti-up, all of the properties that we see for an up quark here are reversed for the down quark. So the anti-up quark's charge is minus 2/3 of the elementary charge. Its baryon number is minus 1/3. And its strangeness is still 0. And we just represent that with that symbol there, a U with a bar across the top. Any anti-quark is represented with that bar at the top, or any anti-particle, in fact, is represented with that bar at the top. For the benefit of my little Lego model, I'm going to use the lime green Lego bricks to represent that. Then we've got an anti-down quark. And again, all of the properties are reversed. So here it's a charge of minus 1/3. So there the charge will be plus 1/3 of the elementary charge. Its baryon number will be minus 1/3. Its strangeness will still be 0. And we'll give it the symbol D with a bar across the top, D bar. So that is anti-down. And then finally, we've got anti-strange. Okay, and again, all of the properties are reversed. So we've got a charge of plus 1/3 there, because the strange quark's got a charge of minus 1/3, and it's 1/3 of the elementary charge. It's got a baryon number of minus 1/3. In this case, it's got a strangeness of plus 1, and it's given the symbol S. with a bar across the top. Okay, and I'm going to represent that one with a blue Lego brick. So in a dark green for the anti-down quark. Okay, so when these particles interact and form other particles, they always form particles called hadrons. Okay, so a hadron in general is a particle made of quarks. Okay, so any particle which consists of quarks is going to be called a hadron. We've then got that split into two other categories of particles. We've got baryons, and baryons are particles which are made of 3 quarks and a group of particles called mesons, which are particles made of a quark, anti-quark pair. Okay, and there's a set of rules which govern how these particles can combine and how they can come together. And that's what I'm going to go on and talk about next. Okay, as I mentioned previously, talking about baryons, they're particles which are made up of 3 quarks. And there's rules that come together with those 3 quarks when they come together, which the first of which says that the baryon number must be equal to 1. And the second rule is the charge must be an integer value. So that's +1, 0, or -1. But if we produce a particle with 3 antiquarks, we get something called an antibaryon. And that antibaryon will have a baryon number of -1. But again, the charge must be an integer. So it will always have a charge of either +1, 0, or -1. Okay, and the most common types of baryons that you're going to come across will be protons and neutrons. So I'll talk about those to start with. And you know from doing even GCSE chemistry that a proton will have a charge of +1. So we need to find a combination of our quarks that we talked about previously that comes together to give us a charge of +1 and a baryon number of 1. Okay, now if I take any 3 baryons and put them together into a particle, that's going to give me a baryon number of 1, because each of the baryons has an individual baryon number of +1/3. In the case of a proton, it has 2 up quarks and a down quark. Okay, so for that proton, the baryon number is +1/3, +1/3, +1/3. So the baryon number equals 1. The charge, I'm going to give that the symbol Q there, is going to be +2/3, +2/3, -1/3. So 2/3 plus 2/3 minus 1/3, which equals 1. Okay, so these particles, these 3 quarks here, satisfy the conditions for a proton. It's got a baryon number of 1, which meets our rule there, and it's got an integer charge of +1. I'll make that a plus there just so it's nice and clear. Okay, so that satisfies the criteria that we need to use there for this being a baryon and for being a proton. It's got a positive charge of 1 and a baryon number of 1. But if we look at a neutron is made up of an up quark and 2 down quarks. Okay, so again, its baryon number is going to be +1/3, +1/3, +1/3. So the baryon number B equals 1. Okay, it satisfies that condition for it being a baryon. The charge is then going to be 1/3 sorry, minus 1/3, minus 1/3 from our 2 down quarks, plus 2/3. And obviously that added together gives us 0. So the overall charge on our neutron is 0, but it has a baryon number of 1. Okay, so baryon number 1 and a charge of 0. But if I made sort of comparable particles which include the antiquarks of those, I get something called an antibaryon. Okay, so if I were to make an antiproton out of 2 up quarks, 2 anti-up quarks and an anti-down quark, I get the opposite properties. So in this case, my baryon number would be minus 1/3, minus 1/3, minus 1/3, which gives me a baryon number of -1, satisfying that criteria there for an antibaryon, which has a baryon number of -1. The charge, on the other hand, would be minus 2/3, minus 2/3, minus 1/3. So that would give me a charge of -1. Whereas if I did the same thing with an anti-neutron, my baryon number would still be -1 because I've got minus 1/3, minus 1/3, minus 1/3. But my charge would be minus 2/3 plus 1/3 plus 1/3, which gives me a charge overall of 0. In addition to our baryons and our antibaryons, we've got another group of baryons that we need to know about, which include strange quarks, and we just call those strange baryons. In the case of your A-level physics course, this just includes a group of particles called sigma particles. Okay, so anything which is a baryon which contains a strange quark is a sigma particle for your A-level physics course. And we get 3 types of them. We get sigma plus, we get sigma naught, and we get sigma minus. In the case of a sigma plus, that is made of 2 up quarks and a strange quark. And again, we can go through and we can test the rule and make sure that our particle satisfies these criteria up here. It's got to have a baryon number of 1, it's got to have an integer charge of +1, 0 or -1. And I've got plus 1/3, plus 1/3, plus 1/3. So there my baryon number is 1. The charge in this case is going to be plus 2/3, plus 2/3, minus 1/3. So that gives me a charge of +1. Then, if I take a sigma naught, that's got the quark combination of up, down, strange. And again, we can check that it satisfies the criteria for our baryon number, plus 1/3, plus 1/3, plus 1/3. And I always encourage people to go through and do these checks to make sure that the particle that they're talking about, or the particle that the question is asking about, does satisfy the criteria for that particular type of particle. Then the charge, up quark has got a charge of plus 2/3, down quark has got a charge of minus 1/3, and our strange quark has got a charge of minus 1/3. So that gives us a charge of 0, and that's where the symbol there comes from. So it's a sigma naught because its charge is 0, whereas the sigma plus is a sigma plus because it's got a charge of +1. Then, if I talk about a sigma minus, that's made of down strange. So again, it's got 3 quarks. It's got 2 down quarks and a strange quark. And again, we can do the check. It's got a baryon number, minus 1/3, minus 1/3, minus 1/3. Sorry, plus 1/3, plus 1/3, plus 1/3, which gives a baryon number of 1. Then, if we check the charge, it's minus 1/3, minus 1/3, minus 1/3. So the charge there will be -1. So the sigma minus comes from the fact that it's got a charge of -1. Okay, so that gives us our 7 types of baryons that we need to know about. We've got our protons and our neutrons, our antiprotons and our antineutrons, and our sigma baryons. And remember that those sigma baryons are strange baryons. They've got 3 quarks. They still satisfy the criteria for a baryon. They've still got a baryon number of 1. They've still got a charge of +1, 0 or -1, so it's still got integer values there. As we did with our protons and neutrons, we can also make antiparticles of this. Okay, so I'm going to pause the video there very, very briefly, and I'm going to give you opportunity to see if you can figure out the quark combinations for the antiparticles of these. So what would the antiparticle of a sigma plus be, of a sigma naught, and a sigma minus? Okay, so I've put together the anti-sigma baryons there, and you can see that whereas my sigma baryon was made of an up-up strange quark, the anti-sigma is made of anti-up, anti-up, anti-strange. The sigma naught, instead of being made of up-down strange, is anti-up, anti-down, anti-strange. And then the sigma minus is made of anti-down, anti-down, anti-strange. And again, we can do our test. I'll only do it with one of them because I think you're starting to get the idea. But the baryon number there is going to be -1/3, -1/3, -1/3. So the baryon number for these antiparticles, these anti-sigma particles there, is -1. The sigma plus, the charge, an anti-up quark has got a charge of -2/3, -2/3, and the strange quark has got a charge of -1/3. So the charge there would be -1. Okay, so hopefully that gives you an idea, very, very briefly, and just a quick bit of revision on baryons. We'll move on next and we'll start having a look at some of the mesons. Okay, as I said at the start of the tutorial, mesons are particles which are made of a quark and an antiquark pair. And they follow, again, a similar set of rules, but they must have a baryon number of 0. And again, their charge must be an integer. So they always have a charge of +1, 0, or -1. So let's have a look at a couple of the particles that we can sort of make when we come to that. Because we're talking about quark and antiquark pairs, we always have to have something like an up quark paired with another particle. Okay, and the first one that I'll talk about is an up quark paired with an anti-down quark. Okay, so that has the symbol up, anti-down, and it forms a particle which is known as a pi plus. And that pi plus particle there, its baryon number is given, it's got to be 0 by virtue of the fact that it's got a quark which has got a baryon number of +1/3 and an antiquark which has got a baryon number of -1/3. So +1/3, -1/3 gives us the baryon number which is 0. But when we look at the charges, the charge of the up quark is +2/3 and the charge of the anti-down quark is +1/3. And that gives us the overall charge of +1. And again, that's where the sign comes from on our pion. Okay, so that's a pion and it's a pi plus particle. We could also make something called a pi minus. Okay, and I'm going to pause the video again there and just give you opportunity to see if you can figure out what the quark combination would be for that pi minus. Okay, there we go. Pi minus is made of an anti-up down quark and antiquark pair. So we've got the down quark and the anti-up quark there. And again, we can check our numbers and we'll talk about the baryon number and the charge. And here we've got a baryon number of -1/3 from our anti-up quark. and a baryon number of plus 1/3 for our down quark. And that gives us an overall baryon number of 0, so it satisfies our first bit of criteria there that the baryon number for a meson has to be 0. And then when we're talking about the charge, the anti-up quark is going to have a charge of minus 2/3, and the down quark has got a charge of minus 1/3. So overall the charge on that will give us -1, so therefore we get a pi minus particle. Okay. As we had with our baryons, we also get strange mesons, and that forms a group of particles called kaons. And again we get K plus, K naught, and K minus kaons. So if I had a K plus particle, that would be made of up anti-strange. So it's got a strangeness there of +1. A K naught, there's two combinations of quarks that we can use to get a K naught. We can have down anti-strange, or we can have anti-down strange. And then a K minus gives us anti-up strange. So what I'd like you to do now, if I pause the video again, is just give you a second, and I want you to test the baryon number and the charge, and just see if you can follow these rules, follow these steps, and just show that these particles satisfy our first two criteria at the top here, that the baryon number must be 0 and the charge is an integer value. So for each of the particles, what is the baryon number and what is the charge? Baryon number, charge, baryon number, and charge. Okay. Okay, so there you have it. I've done the test and I've run through and I've said that the baryon number for our K plus is +1/3, -1/3, and that gives us an overall baryon number of 0, which satisfies the first criteria that the baryon number must be 0. And then for the charge, I've got +2/3, +1/3, giving us an overall charge of +1, which is an integer value, and it also satisfies the sign there for the K plus. So that works and that works. Then you can see I've gone through, and I'll let you check your answers against what I've put there for the kaons, for the other kaons. The K naught, I've only done the down anti-strange, but you can also do the test there for the anti-down strange too. Okay, so hopefully that brings together some of the main points to do with quarks, hadrons, baryons, and mesons, and the different rules for combinations of those particles. The next tutorial that I'm planning on doing will look at some of the interactions, so the strong interaction, the weak nuclear interaction, and so on like that. So please make sure you come back, make sure you have a look at the videos, and ask me any questions in the comments section if you need to. Thanks for watching. Bye bye.